We're going to continue our study on sets today. So the first thing we're going to talk about is set operations. Now the complement of a set is the set of all elements that do not belong to set A. Typically when we're talking about the complement of a set, we are typically talking about some what we call universe of elements, and we want to talk about whether or not certain elements are within set A or not in set A. So the complement of set A, the way we would notate it, is A with a little apostrophe, and we read it as A prime. Now just as kind of a visual for us to see what this looks like, let's say you have this rectangle out here, and that represents U, the universal set. And then set A is everything that's inside of that circle there, and everything that's not in set A, that's everything outside of that set, is the shaded part, which is what we call A prime. So that's the complement of set A. Let's take a look at example 1. So we're letting the universal set be U, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we're given set A and set B. We're going to find each of the following. So the first is the complement of A, so everything that's within that universal set that is not in A. So it looks like that would be, let's see, 3, 6, 8, 9, 10, 11. So that would be A prime. Now to find the complement of B, so B prime, everything that is not in set B but is in the universal set, that's going to be 1, 3, 6, 8, and 10. Now the next one, this says the complement of the empty set. So anything that's not in the empty set is going to be the universal set. So that would be U. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the last one here, this is A prime prime, which means everything that is not in the complement of A. That actually just means everything that is in A. So that would be 1, 2, 4, 5, and 7. A couple more things with set operations. First is the intersection of two sets. When we talk about the intersection of two sets, we refer to the set of elements that are in both set A and set B. Now the way we notate this is with kind of what this looks like, an upside down U. That's the intersection. So the intersection of A and B is A, and then with the little symbol in between, and then B. And the way you read this is A intersect B. Now as a visual to represent exactly what this looks like, here's your universal set, here's A, here's B, and the intersection of A and B is the part that overlaps this part right here, and we call that A intersect B. Now, important to note while we're talking about the intersection of two sets, if sets have no elements in common, we call them disjoint sets. So here's A, here's B, there are no elements in common, they do not overlap, so we would say A and B are disjoint sets. Take a look at example 2. We have the universal set U going from 0 all the way up through 10, and then we're given sets A, B, and C. Find each of the following. Alright, so A intersected with B, we have to find what's common with A and B. Now because these will get a little bit more complicated, I'm going to write them out. So set A is 3, 6, and 9, and set B is 2, 4, 6, and 8. So now looking between those two sets, we want to find the things that they have in common. In this case, it looks like the 6 is the only thing they have in common, and so that is our intersection of A and B. Alright, next we're going to find A intersect B prime. So remember that B prime, the complement of B, is going to be everything that's in the universal set but not in B. So we know that in set A we have 3, 6, and 9. In the complement of B, that's everything that's not in B, so that looks like it would be 0, 1, 3, 5, 7, 9, and 10. Now that we have that set written out, now we can look between these two sets and see what they have in common. It looks like here we just have the 3 and the 9 in common, so A intersect B prime will be the set with the elements 3 and 9. Alright, last one we have A intersect C, so we're going to look at the elements of A and the elements of C, and we're going to compare those two, and we want to find what they have in common. Taking a look here, it looks like there are no elements that they have in common, which means that A and C are disjoint sets, so we would say that the intersection of A and C is the empty set. There are no elements within that set. Next, we're going to talk about the union of two sets. So we talked about the intersection of two sets being the set of elements that they have in common. Now, when we're talking about the union of two sets, you can imagine we are literally uniting the elements of both sets. So the union of two sets are the set of elements that belong to set A, set B, or both. The way that we notate this is with what looks like a U, and you would read it as A union B. In terms of a visual, here's your universal set, and we have set A over here, we have set B over here, and everything that's shaded right now, so everything that's in the middle, anything that's in A, anything that's in B, all of that all together is what we call A union B. So we're really uniting everything in A, everything in B all together. Typically, if something is in both A and B, we would only write it once. There's no need to write it more than once. All right, so look at example 3. It says, let the universal set go from 0 all the way up to 12. And then we're given sets A, B, and C. Find each of the following. So the first one, we have A union B. So we're going to write all the elements that are in A and in B and combine it into one set. Again, if there's anything that is in both sets, we'll just write it once. So combining these both, we have 1, 3, 5, 6, 7, 9, 11, and 12. So that would be A union B. All right, next we have B union C. So now we're going to take all the elements of B and all the elements of C, put them together. If there are any repeats, no need to write them a second time. So this would be 1, 2, 3, 4, 5, 6, 9, and 12. All right, for the last one here, A union B intersected with C prime. Okay, now A union B we actually found in part A, so we'll go ahead and use that. Now C prime is everything that is not in the set C. So that would be 0, 6, 7, 8, 9, 10, 11, 12. So those are the two sets we're working with. Now we have to find the intersection of those two sets. So remember, the intersection is what both sets have in common. So it looks like that would be 6, 7, 9, 11, and 12. So in terms of set operations, we talked about the complement of a set, so anything that's not within that set but is in what we call the universal set. We talked about the intersection of two sets, so anything that both sets have in common. And we talked about the union of sets, so combining everything into one bigger set without any repeats.